one was honestly the hardest one.
But we don't do it for one way.
Log A2 is 5, okay, so that's our starting point. Find the exact value of log A32. Okay, we need then some version of this, out of this. So that's 32 is 2 to the power of 5. Using log rules, then that's 5 log A2. And we know that this is 5. So that's 5 times 5, which is 25.
Oh.
And
Wait.
next one. Yeah, I'm waiting. No, you're not buying it?
Wait.
No.
Oh, I see now.
Okay, next one then we have log root A 2. That's not the right base, but we can use the change of base rule. Pick our own base. We want log base A as our base. So we can do this.
Oh, you can?
Yeah, and this. Pick your own base.
Yeah, that's how much
It's one of the log rules. We did it in logs. So this I know is 5. The top is 5, but the denominator here is log A half, and then you can put the half down in front, the same. So that's a half log AA, and AA is log AA is 1, of course, and that's 10. The last one you can just do in your calculator. Okay. So change of base rule. You might need to familiarize yourself with that from the book, if you want. The proof, was it okay?
Easy. Yeah.
Easy. Okay, maybe I'll do the other proof.
Easy.
You can check the mark scheme for that. The extension of the binomial theorem, I think once you knew what to do, was pretty straightforward, but you may have panicked if you saw it and you didn't know what to do. A quick rewrite of it, if you got x over 1 minus x, is that 1 minus 1 plus x? Yeah. Squared, you can rewrite this as x times 1 plus x to the minus 2. And this is my binomial I can use the extension of go straight to the formula booklet, and it's already in 1 plus, so that's useful. And then you can just use the extension. So you go to the extension of the binomial theorem, start to fill in for a and b, and you should be left with x, and then you have 1 plus n, which is minus 2, and this over this, which is just this, and so on. You do that, okay? Everybody get that, or you want me to finish it? Anybody want me to do this out? Quick nod. No? Okay. Let's continue.
It just simplifies into that, right?
Yeah, so it's whatever, it's b over a, and then the next one is x minus 2, 1 less, and then 2 factorial and x squared. I'll just finish it now, might as well. So that's when I multiply in the x, I get x here. Multiply in the x, I get a minus 2x squared.
Why don't you simplify first?
Well, because I can just do it all at once. 2 into 2, minus 1 times, minus 2 into 2, minus 1. So that's minus 3, which is plus 3. X squared.
Cubed.
Oh, cubed, yes. Sorry, forgot. Multiplied by this x. And that's what we need to show. Stop this. Okay. Next one is our linear systems, matrices type 1. I think most of us got this one. Does anyone want me to do it? Anyway. Yes? Okay. Let's have a little look then. Make sure you're all on the right track. We have we converted into a matrix style one. We get 1, 1, 4, 1, 3, 2, 16, 5, 4, 2, a minus 1, b minus 4. So the one key here is obviously to be pretty clinical when you do this and not make any arithmetic errors. So we're looking to get it down into the position where we've got this or similar. You don't necessarily need this to be positive 1. So something similar to that. So we already have the 1 here, so we're going to work getting these two to zeros. So 1, 1, 4, 1 is our first line. I'm going to use row 1 to remove the 3 here. So I'm going to say row 2, take away 3 row 1s. Might work for me. 0. Row 2 is this, take away 3 is minus 1. Row 2 is this, take away 3 of these is 4. Row 2, take away 3 of these is 2. Just make sure I'm right. And then row 3 minus 4 row 1s, I suppose, will give us this one. So that's this, take away this, which I knew was going to give 0. This, take away 4 of those, gives negative 2. This, take away 4 of those, is a minus 1 minus 8, is it? No, it's minus 16, that's terrible. A minus 17. And then this, b minus 4, take away 4 of these, is take away another 4, which is minus 8. We get this? Okay, we've almost made it. You can, if you want, switch the signs here, multiply across by, if you don't, most of you probably did this, minus 4 and minus 2. Most of you did that, just multiply row 2 by negative 1. And then row 3, we got to use row 2 to get rid of row 3. Why can't we use row 1? I think someone was...
Can we multiply row 2? Why don't we do row 2 times 2, so then you could just equal it out?
That's for this one? Yeah, that's what we're going to do. Yeah, I can't use row 1 to get rid of this because you'll end up with a number in this position again. So you've already got a 0 here, so we're going to keep it 0. So you do row, we'll just use these rows. Row 3 minus 2 row 2s from up here. So I get 0, 0, this, a minus 17 minus another 8, I think, gives a minus 25, and b minus 8, yeah, minus, yeah, it's b minus 12. Okay, so we get to this stage. Is it not right?
It is correct.
Okay. I'm subtracting, I'm doing this row, remember. I'm taking what this, so minus 12 minus another 4.
Why can't we just...
Or minus 8 it was, minus another 4.
Times 2 row 2.
Yeah, this row 2,
Oh, okay.
not this row 2. Yeah.
Why can't we just multiply row 2 by 2, and then you'd see that negative 2 equals negative 2, 8 equals a minus 17, and 4 equals b minus 8.
No, because those are coefficients for z.
Yeah.
Negative 1.
What's the you want me? At which stage you want me to just multiply row 2 by something? To here? And to get to the next line?
So just do row 2 times 2.
This times 2 here, and then they would match each other.
Yeah.
And then what?
And then you could just see a minus 17 is 8, and b minus 8 is 4.
A minus 17. What about this C?
What about it?
That equals that. What about that? What are you trying to show?
I'm trying to show that it's like they're the same. Like I'm not
Oh,
really
you're
focused on row 1. I'm just focusing on row 2.
To what end are you showing they're the same? If you're trying to solve it?
Yeah. So if you're trying
Oh,
to
you
find
can
a-
simultaneous equations solve it at this stage if you want, yeah.
Like more complicated.
I don't know. That's just an
Yeah, we could, but you're better off doing this because this allows us to get the 3 different answers at the end. It's easier. So we're looking then at the 3 different answers. Find the condition the system has no solutions. What do we want for no solutions?
Something equals
0,
0.
0, 0, 0, 0?
No, 0,
No, that sounds like...
something.
yeah, so no solutions at the end. We want 0, 0, 0, a number. Yeah. 5 is not the number. For infinite solutions then is different. That's where we want all the zeros, yeah.
Wait, why do you want all the zeros for an infinite solution?
Because why do I want all the zeros?
Yeah, why does that make an infinite solution?
It kind of means that the lines are on top of each other. So there is answers all along the plane, because two of the lines sit on top of each other, which we'll look at in vectors a little bit more. It's a visual. It's like a three-dimensional thing where you get more than one answer. It's like a constant answer. The answer is a line in itself.
Wait, how would we make it so that, well, like what B cannot be? Just
Okay,
like-
yeah, I haven't got there yet. Okay, so if I want this to happen, I just need this to be a 0, this to be a 0. So A minus 25 equals 0, so A is equal to 25. Okay, if A is 25, then I get no solutions. What about B though? As long as B is a negative, positive 12.
Oh, that also can't equal.
Because if this was a 0 as well, then it's this one.
Yeah.
So this is our first answer for this one. The second answer then is for
One solution.
one solution. For one solution, what do we want? We want a number here, a number here. Yeah, we just want a number here, a number here. So A cannot be 25 this time. And B can be just anything, because you could get an answer of Z being 0, because that coordinate could be on the Z axis. And so that's part B. And then part C then for infinite solutions, I think most of us got this. A is equal to 25, is it? And B is equal to 12. So they're both 0. Make them both 0. If these two are zeros. So we're looking for this one. Okay. And then there was the thing about, all right, how do I finish this question if we need to find then the general solution or all the solutions? That means we have this case is in play, so we have zeros all across the line. And in that case, we say, right, we let, like it's a free variable, we let Z equal to T. Or you don't, T is not the only letter you could use. Like some people like to use lambda. I think the mark scheme used something else.
The mark scheme just said find the general solutions.
Yeah.
Said in terms of x and y.
Yes, okay, so that's what we're going to do, yeah. And you'll see what this is going to look like in a second. So to do that, we let Z is equal to T. We presume this is 0 and 0. So we got, in the next line then, so we're dealing with this solution now. Yeah, so y minus 4 times, that's Z, but we just said Z was T, is equal to negative 2. And then, and Z is T. So remember, this is X, Y, Z. I can write it as a Z if you like, and then say Z is T afterwards.
Why do we have to change it to t? The mark scheme just left it as z.
Well, you could, because Z is T, so you can, yeah. I think it's more accurate to use T, but yeah, because at the end you're going to give it, you'll see in the end anyway. Y is equal to 4t minus 2 is one way of writing y. We'll look at this again in a second. And x plus 4t minus 2, so I'm doing this one now. X, y, 4 times z, 4 times t is equal to 1. I think I get x is equal to 3 minus 8t. Okay, but then if you do want to give the general solution, you got to let them all equal t instead of x. These are the separate parameters, like all along the line. Vectors will probably sort this out for you visually, what this would look like when we get to it. So we rearrange x minus 3 all over negative 8, or some version of that, is equal to, because that equals t. This one will be y plus 2 over 4, which is equal to z. This is the general solution, yeah.
So we're just doing x equals y?
X is not equal y. No, we're just letting them all equal the same thing. We let them all equal t. And then, so if they all equal t, they all equal each other at that particular moment in time. Okay. No. Thank you. Oh, joy. Right. I finally got my head around this one.
Here's Lindsay.
All right.
Can we do that?
For the YouTube channel. For the views.
No. Yeah, well, you can. Well, maybe I'll do my explanation, and if you're not happy with that, I'll let them do their
I'm
explanation.
not happy with it.
No, stop.
Content machine.
Okay. What's wrong?
Ryan might cover the whole screen.
Oh, okay.
That's what I said.
Okay, so we have a code made out of A, B, C, D, and numbers 0 to 1. So A, B, C, D, 0, 1, 2. Yeah? No?
I thought we weren't meant to do that.
No, I'm just saying this is what's this is my start point. Okay, yeah. So most of us figured out the best way of figuring out this, where 3 cannot be together and 4 cannot be together, is to go the opposite way and figure out where they are together. So that started off with, all right, how many code could you make in total? There's 14 options for the first one, 13 options for the second block, and so on. So that's 14 factorial, and then you take away 2 things. You're going to take away where 3 are together, and you're also going to take away where 4 are together. And when I say 3, I refer to 3 letters are together.
Wait, why is it 14 factorial?
There's 14 things there. There's 14.
Well, can't you repeat the same number multiple times?
You can, yeah.
So why is it
Oh, you can't. No, you can't. Can you? No, it's.
there is no restriction on the order.
Which number? But you got to use them all.
Well, you have to use them all.
Yeah, yeah.
Where does it say that?
How do you know that?
Yeah.
I know. Yeah, it's a bit vague, isn't it?
Wait, where does it say you have to use
No.
It doesn't say that there's any, like,
Why would there math positions?
so then that
Barcode string it's created from the no letters may be written consecutively in marking this restriction on okay, no, it hasn't. Yeah, it doesn't state it, but this is what they wanted to state. It's not very clear. This is an IB question. This came up in an exam, so.
That's horrible.
Yeah, it's pretty horrible.
That's so stupid.
It was pretty horrible, yeah. Okay, but let's get the answer to it. All right, so 14 factorial, not an issue, but where 3 is together, let's do first, which is the hardest one. Where 3 is together, we'll start off with the numbers. The numbers can be in any, there's 10 there, and they can be arranged in 10 factorial different ways. They can be, does that make sense? They can be put in any order of the 10. Our three letters, though, we're putting together. We're putting 3 of them together. So that's 4 letters, and we choose 3 of them. Happy with that? Any 3, doesn't matter. But they can be arranged in their 6 different ways. 3 factorial ways. So if A, B, C can be arranged 6 different ways, can't it? 3 options here, 2 options then, and 1 option for the last. So they can be arranged 6 different ways. That would give 6 different codes, wouldn't it? Every time it's
Wait, sorry. Is that not a form for musicians to do that?
No, this is picking the 3 letters. Because there's also A, B, C is different than D, B, C. That's
4 times 3 times 2?
this is just 3 together.
Yeah.
No, when you pick the 3, this is picking the 3, and this is arranging the 3.
Oh, because you're taking one out and it's not.
Yeah, it's not included, yeah. Okay. All right, then.
Consecutively means not like after each other. It doesn't have to be in order.
No, it doesn't have to be in alphabetical order, no. Okay?
Doesn't 4 choose 3 already?
No, 4 choose 3 picks which of these 4, which 3. The 3 factorial then is the different amount of ways that could be arranged. So A, B, C, B, C, A, and so on.
Wait, I still don't understand why you can't repeat the same letter, because in the next question.
In the one at the end, you can, yeah, I know, yeah. It's vague. But this is one they didn't want you to repeat the same letter.
But if you did the math, then
I know, yeah. I know. They should have been more vague. You've got to use all.
Is in a barcode you can't repeat letters?
No, I don't think so. I think they should have been more specific.
Yeah, okay.
Okay, but that's not it. That is not it. And this is the bit that it was difficult to get your head around. Where do the numbers and these letters fit? because it's quite important that this block of 3, let's say it's A, B, C, and it's D, this block of 3 are separated. So how many spots can it go in? They can go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. Yeah? There's 11 places for it to go. And we're going to choose 2 spots for them.
This is not how they did it.
Probably not. I don't know how they did it. This is 11 spots, and you choose 2 of them.
Wait, I want to draw that. 2.
Yeah, 2. One for this guy, one for this guy. 11, choose 2.
Yeah, that's right.
Yep. Okay. But, no, maybe not what you did.
Yeah,
But-
11 choose 2 times 10 factorial. Because there's 10 different ways.
Oh, we've already arranged these 10 in multiple different ways. We're just saying the slots. But that in itself, yeah?
Wait, why only 2? Why not 4?
Because this is like a block, and this is a block. Because this is all together, it has to be together. Yeah. And that can actually be arranged the other way.
Wait, why is this choose 2?
Because those 2 are 2 blocks.
Yeah, this is one option, this is the second option. There's 11 spots to them, and we've 2 things to go in there.
Ryan, say wait,
Yeah, there's 11 things, we choose 2 of them. 11 spots, we choose 2.
Oh, we're making it ABC 1.
And but also, if you put them in those slots, let's say we put it here and here. Let's say this was ABC and this was D. If you count that once, you have to count it twice because it could have been swapped around. So that's why I'm multiplying that by 2.
Wait, what?
So this 11 choose 2 just puts them in these 2 spots. Or at all the different combinations of those 2 spots. But that doesn't take into account that actually it would be a different code if they swap positions. So there's double the amount. So that's why I'm now multiplying by 2. I'm counting for this one, and if it was D here, and yeah. So that's why I'm multiplying by this 2.
This is too much for me.
Yes.
Yeah.
This is really, really, really difficult. Now I need to subtract. That's it. That's as much. That's
Put 3 together.
yeah, 3. That was harder. Way harder than 4 together. 4 together is start with your 10 factorial again. This time, the 4 letters are together. So you can do 4, choose 4 letters, but that's pretty pointless. That's just going to be 1. There's only one way to choose 4 out of 4. But you could arrange them 4 factorial different ways. As in A, B, C, D are now one block, but they can be all switched around. Those letters can be arranged in 4 factorial ways because there's 4 options, 3 options, 2 options, 1 option.